Okay, we're going to cover some basic examples of radicals in this video. The 6 problems that you see on the board here. In all of these, we're trying to simplify the radical as much as possible, pull everything out that we can. We also need to worry about reducing any fractions that we see, and we have to rationalize fractions, meaning that we cannot end up with radicals in the denominator of any fractions. Let's go ahead and hit our first example here. We're taking the square root of 48. Since this is a square root, well, it's not written, but it's implied whenever it's not explicitly written. So we've got a square root. We're going to be looking for pairs of factors, groups of 2 inside of here. I'm going to do a factor tree on 48 to see what's in here. So that's 12 times 4. 4 is 2 times 2, which are both prime. 12 is 3 times 4. And we got another couple of 2's here from that 4. So we can now write out the prime factorization of 48. It's going to have a bunch of 2's and a 3 in there. And again, because we're talking about a square root, we're looking for groups of 2. So we've got a couple groups of 2's that we can bring out. We've got a 3 that's going to be stuck on the inside here. Let's bring these 2 groups of 2's out to the front. And in our final step, we'll go ahead and multiply those 2's together to get 4 radical 3. Okay, next example, very similar. We've got a cube root this time. We're also dealing with some variables. We've got a coefficient on the outside. And we've also got a negative on the inside. Now, because this is a cube root, that's an odd numbered root, we're allowed to just bring this negative right to the outside. So let's just go ahead and do that right off the bat. We are going to end up with a negative 5 on the outside. And the next thing I'm going to do is try and break up that 500, see what we've got inside of there. So 500 could be 50 times 10. 50 is 5 times 10. 5 is prime. 10 is 5 times 2. We get another 10 here, another 5, and another 2. So if we write out our prime factorization, we're going to have a couple 2's, a few 5's. We've got some x's in there too. X cubed would be x times x times x, and then we got a single y in there. So we're going to try and group up. This time we're looking for groups of 3. Got 3 5's there, and we got 3 x's here. So we should be able to bring those out to the front. Everything else is going to stay inside. So the negative 5 is going to stay out here. We've got a 2 and a 2 and a y on the inside. And we've got another 5 and another x coming out. All right, then all we need to do here is go ahead and simplify this. Negative 5 times 5 would be negative 25. Get that x there, and then cube root of 4y, and we're done. Okay, next example. In this one, we've got another square root, and we're going to, we got a negative 1 sitting out in front of that thing, so we'll go ahead and leave that there. Let's go ahead and break this down. Now, actually, in this case, since I'm looking for pairs, and I happen to know that 100 is 10 times 10, we can just go ahead and use that as our pair there. Also, we've got a pair of x's here, so that's a second pair that we can pull out. Y is not going anywhere, so this one's actually a little bit quicker to work with. We've got a pair of 10's coming out. We got a pair of x's coming out. We've got a single y left inside, and then negative out in front would stay out in front. So I took a couple of shortcuts there, but this is a relatively simple problem. Okay, we're dealing with a fraction here with radicals. First thing I'm going to do here is see if we can reduce anything. We do have a 49 over 21, and those are both inside of a radical, and that should reduce. This fraction 49 over 21, both of those are divisible by 7. So dividing by 7 would get us 7/3. So let's go ahead and I'm going to rewrite this, keeping my radical up top. I'm going to leave that 5 out in front for now. That 49 over 21 is going to reduce to 7/3. Okay, we also got an n squared on the top and an n cubed on the bottom. We can cancel all the n's on the top with 2 of the n's on the bottom. That's going to leave us with 1 n left on the bottom. So everything's reduced as far as we can. However, we are going to want to rationalize. We're not allowed to have that radical on the bottom. So in order to group up and make groups of 2, I'm going to need to bring in another 3 and another n. So I will be multiplying by the square root of 3n, which will effectively bring another 3 and another n into both the radical on the top and on the bottom. This is going to allow us to group up our 3's and our n's, and everything will come out of the radical at this point, and we won't have anything left in there. So we had a 5 out there to begin with. We just brought out a group of 3's and a group of n's. On the top, we had a radical 7 to begin with. We just brought in a new 3 and a new n. Let's multiply n out and see what we got here. 21n on inside the radical. We got a 15n on the bottom. Now we can't cancel those n's or reduce to 21 over 15 because in both cases you've got one side of the fraction inside of a radical and the other side outside. There's nothing inside of 21 that we can break up and bring out, group up and bring out, so I think we're stuck here. This will be our answer. All right, next example. We're dealing with fractions again. And again, first thing I'm going to do is go ahead and try and reduce. I've got an x to the 4th and an x that are both inside of a radical. We should be able to simplify that. So I'm going to leave everything else alone for the time being. But we can go ahead and simplify that. So that x on the bottom is going to cancel with one of the x's on the top. So no more x's on the bottom. We'll have 3 left over on the top. Okay, we're going to have to get rid of that radical 7 on the bottom. That's my next order of business. We cannot have a radical on the bottom, so I can move the 7 outside if I could bring in a partner for it and group it up. So I'm going to go ahead and do that by multiplying by a radical 7 on the top and bottom. That's going to bring another 7 in here. We'll be able to group those up, move those to the outside, and we won't have any more radical on the bottom, which is great. We still got a 3 on the top, we still got a square root, and we got a 5, and an x cubed, and a 7. All right, I'm looking at that x cubed there, thinking we got 3 x's in there. We should be able to group up 2 of those and bring those out in front with that 3. So let's go ahead and do that. So we got one group of x's coming out in front. That's going to leave the 5 and the 7 and the x behind. 5 times 7 is 35. We got an x left in there as well. And we got a 7 on the bottom. And nothing else we can pull out of the radical. There's nothing else that simplifies in terms of the fraction. And we don't have a radical on the bottom. So this problem is done at that point. All right, last one for this video. In this case, we do have a radical. It's a cube root. We've got a fraction going on. I was actually just a moment ago tempted to cancel the x with one of the x's down there, but we can't do that because one of them's inside the radical and the other one's not. So the only thing that we can really do at this point, that we have to do, is we got to get rid of that radical in the denominator. So we need to rationalize. Right now I'm looking at a single 2 and 2 x's on the inside of here. So I'm starting off with a 2 and 2 x's. I want to bring in some more stuff. I need to make groups of 3 here. So I'm going to need a couple more 2's and one more x in order to group everything out and ship it all to the outside of the radical. So I need to bring in a cube root, and I'm going to need 2 2's and an x. I got to do the same thing on the top. All right, once I've done this, now we've got a group of 2's on the bottom, a group of x's on the bottom. We can bring both of those out. There's going to be nothing left inside of our radical at this point. So we've gotten rid of the radical. On the top, we got an x. We got a cube root of 2 squared would be 4, and an x up there as well. Let's see here. Can we cancel anything? I've got an x on the top and an x on the bottom that are both outside of the radical. So yes, we should be able to cancel those guys out, and that'll get us to our final answer then. We got the cube root of 4x over 2.